Very good afternoon to all of you. Can you hear me? Yes, who is there? मेरी आवाज आ रही है आप लोगों को? Yes or no? Hmm? Please tell me. Can you hear me? जल्दी से बोलो so that I can start the lecture. Probably this will be your last lecture of this semester. Yes, Sonal is saying yes sir. Mansi is also saying good afternoon sir. Prapti, Pooja, Vaishnavi, ट्रिम्फनी इज देयर. अरे वाह, ट्रिम्फनी बहुत दिनों के बाद आ गई लेक्चर को. ओके, तनुजा इज आल्सो देयर. सो मे बी दिस इज योर लास्ट लेक्चर फॉर दिस सेमेस्टर. ठीक है. What we were talking about in the last lecture? We were talking about the MOT. In the last lecture, I think we have seen assumptions of MOT. Up till now we have seen assumptions, then we have seen symmetry symbols for s, p and d orbitals. Then we have applied assumptions of MOT to the octahedral complexes without pi bonding we have seen, and how to fill the electrons in that complexes, that also we have seen in the last lecture. Today we will see the application of molecular orbital theory to the coordination complexes with pi bonding. Means pi bonding is present in the coordination compound, and for such complexes how to apply MOT, that we will see today. Okay, so in the last lecture we have seen filling of the electrons, and from that filling of electrons or electronic configuration according to the molecular orbital theory, we can find out the number of unpaired electrons, and if there is any unpaired electron present in the complex according to MOT, then we can say that the complex is paramagnetic. If no unpaired electrons are present, then we can say that that complex is diamagnetic. ठीक है, ये हम लोगों ने अब तक देखा है. So today we will see next topic, that is application of MOT to the coordination complex which has pi bonding. You know that in the sigma 1 formation, T to G orbital will not take part. T to G orbital doesn't take part in the sigma 1 formations. Why? Because of the lobes. Because of the lobes of T to G orbitals, they are in between the axis. The lobes are in between the axis, and to form a sigma 1 axial overlapping is there. To form sigma 1 axial overlapping is there. That means those orbitals which are having their lobes along the axis, only those orbital they can participate in sigma 1 formation. So only, yes, we have seen. Then p orbitals, then EG orbitals, which is one of the d orbital, that orbital 6 orbital, these 6 orbital they involve in the sigma 1 formation that we have seen. But T2G orbital will not participate in T2G orbital does not participate in the sigma 1 formation, but T2G orbital they can participate in the pi bond formation, that I have seen, that we have seen while discussing the assumptions of molecular orbital theory. ठीक है. So जो T2G orbital from metal and T2G orbital from ligand, they can participate and they forms a bond. They forms a pi bond, and due to this pi bond formation, what happens? Due to this pi bond formation, there is change in magnitude of del O, that is delta of octahedral takes place due to the formation of pi bond. You know that del O is nothing but, what is del O? Can anybody tell me what is del O? I have told you del O. What is del O? And due to this pi bond formation, the magnitude of del O will get changed. So first we should know what is del O. Del O is there, del T is there, del SP is there. What is del O? Can anybody tell me what is del O? Nobody knows what is del O. Del O is delta octahedral. It is the difference between, what? It is the energy difference. Please remember this. It is the energy difference between which orbital? Tell me. It is the energy difference between which orbital? If you have pen notebook, sorry, if you knows the answer, you can write in chat box. So del O is nothing but the energy difference between T2G orbital, that is from metal. Please remember this. It is the energy difference between T2G orbital. Correct. Armia is saying difference between T2G and EG. Not here. In MOT, the difference between T2G and EG star orbital. Please remember this. Because here EG orbital which is lower in energy in case of MOT. Correct. Sonal ने सही आंसर दिया है. Difference between T2G and EG star orbital. Please remember this. While you are talking about the MOT, the del O is nothing but the difference between T2G and EG star orbital, which is anti-bonding orbital. Please remember this. So this T2G orbital is from metal. Please remember this. This T2G orbital is from metal and EG star orbital. So the Arma is saying okay, chalo, no problem. So the difference between T2G orbital, which is originally from metal, and EG orbital, that difference is called as a del O. And this del O, or the magnitude of del O, is get changed due to the formation of pi bond. So what happens? What happens after the formation of pi bond? How this magnitude of del O is get changed? When it will get decrease, when it will get increase, that we will see in today's lecture. Okay, so let us start today's lecture. So this is your lecture number 3, not 2. This is your lecture number 3. Please remember that. This is your lecture number 3 of molecular orbital theory. So today we will see this treatment, that is molecular orbital treatment to octahedral complexes with pi bonding. That means those octahedral complexes which has pi bonding or which contains a pi bonding. So here two types of bonds are present. First bond is sigma bond, which is formed due to the axial overlapping, and then another bond is that is called as a pi bond, which is formed due to the sidewise overlapping. And due to this formation of pi bond, the magnitude of del O will get changed. How it will get changed, that we will see today. So this pi bonding takes place between T2G orbital of ligand with T2G orbital of metal. So this pi bond, I have told you, this T2G orbital, they does not take part in the sigma bond formation, but they can take part in the pi bond formation. So T2G orbital from metal and T2G orbital from ligand, they will get combined. So 3 T2G orbital from ligand and 3 T2G orbital from metal. So total 6 atomic orbital they get combined and forms total 6 molecular orbital. And out of that 6 molecular orbital, 3 molecular orbital they are lower in energy, they are called as bonding, and 3 they are higher in energy, they are called as anti-bonding. Okay, so here also again two cases are there. Here also again two cases are there. Case 1 is nothing but this is case 1. Case 1 क्या है? Write down this case 1, filled ligand orbital. So in the case 1, ligand orbital they are filled with electrons. So they contain electrons. So they can act as a donor. They can act as a donor of electrons, and they are low in energy. So this is the first case. Case 1 is nothing but the filled ligand donor orbitals of low energy, and case 2 is empty ligand orbital. That means this ligand orbital they do not contain electrons. So they can act as an acceptor. They can accept the electrons from metal. So and they are high in energy. They are high in energy. So case 1 is filled ligand donor orbital. Filled है मतलब they are contains the electrons and they can donate the electrons to the metal, and they are lower in energy. And case 2 is empty ligand orbitals. Case 2 is what? Empty ligand orbital. So there are no electrons in this ligand, so they can accept the electrons from metal and they are high in energy. So two cases are there. We will see, or we will discuss this both the cases one by one. So let us start with the case 1. Case 1. This is the molecular orbital diagram for case 1 of pi complex. Okay. Now this you remember very well. This is a ये आप लोगों को दिख रहा है ना यहाँ पे. This is the energy del O of sigma complex. ये आप लोगों को दिख रहा है, ये क्या है? ये आप लोगों ने sigma complex में देखा है. This you have seen in sigma complex. This is T2G orbitals and this is EG star orbital, and the energy difference between this T2G and EG, it is called as a del O. The energy difference between T2G and EG, they are called as a del O. So this T2G, they are from metal orbital. This T2G, they are metal T2G orbital, and here again T2G orbitals are there. So these T2G orbital, they are from Ligand orbital, which I have shown in green color. These T2G orbital, they are from Ligand, and this T2G we have that I have shown in red color, they are from metal. So what happens, this T2G orbital from metal and this T2G orbital from Ligand, they get combines and forms a T2G orbital. Here I have written T2G orbital, which is lower in energy, and at the same time again this T2G orbital, they will get formed which is higher in energy, so it is called as a T2G star, which indicates it is a anti-bonding orbital, which indicates star indicate it is a anti-bonding orbital, and this T2G orbital is a bonding orbital. Why? Because it is lower in energy, so here if you see, this is a pi bond, or we can say it is a pi orbital, and here which is having higher energy, so it is a pi star orbital, and this EG orbital, they will remain unaffected, and now this energy difference in sigma complex is high. If you see here, the gap between T2G and EG star, which is in sigma complex, is high, and that gap in pi complex, what happens, that this T2G star, this T2G orbital from metal, they get their or they get raised in energy, so that what happens, उसकी एनर्जी क्या हो जाती है, हाई हो जाती है, so that the gap between T2G star and EG star orbital, now here this T2G orbital, here they becomes T2G star orbital. So जो एंटी बॉन्डिंग ऑर्बिटल है ना T2G ऑर्बिटल, इट इज फ्रॉम ओरिजिनली मेटल T2G ऑर्बिटल. जो मेटल के T2G ऑर्बिटल है ना, उसकी एनर्जी क्या हो जाती है, high हो जाती है. So this T2G orbitals from metal, now it becomes T2G star orbital, and here in pi complex, what happens, the del O is nothing but the energy difference between T2G star and EG star. So please remember, in case of CFT, del O is energy difference between T2G and EG. In case of sigma complex, the del O is nothing but the energy difference between T2G and EG star, and in case of pi complex, the energy difference between del 0 is energy difference between T2G star and EG star. Please remember this. Now what happens, the magnitude of del O get decreased in the pi complex. The magnitude of del O get decreased in pi complex, and whatever this bonding orbital, they are original ligand T2G orbital. They are original ligand T2G orbital. Ligand orbital जो है ना, ligands के T2G orbital, they goes lower in energy, and metals के T2G orbital, they goes higher in energy. So due to this, what happens, let us see here. Read this carefully or listen this carefully. Del 0 or del O in a sigma bonded complex, that is the difference between T2G and EG star, becomes the difference between T2G star and EG star, and due to this, what happens, the magnitude of del O is get reduced. Due to this, what happens, the magnitude of del O is get reduced, and as a result of this, the complex becomes unstable. Now I have told you, the higher will be the gap between T2G and EG orbital in CFT also. I have told you, the higher is the energy difference between T2G and EG, stronger or stable will be the complex. जितना ज्यादा गैप रहेगा, जितना ज्यादा मैग्नीट्यूड रहेगी डेल ओ की, उतना ही वो कॉम्प्लेक्स क्या होता है, stable हो जाता है. Now here after the pi bond formation, what happens? The gap or the magnitude between T2G star and Eg star is get reduced, and as a result of this what happens, क्या हुआ है, gap कम हुआ है, energy difference कम हुआ है, so as a result of this the complex becomes unstable. तो क्या हो जाता है, आफ्टर द कॉम्प्लेक्स फॉर्मेशन, सॉरी आफ्टर द सिग्मा और पाई बॉन्ड फॉर्मेशन, इफ T2G orbital they get raise their energy, and due to this increase in energy that complex becomes unstable. Please remember this. अगर मेटल के T2G orbital की एनर्जी हाई हो जाती है तो कॉम्प्लेक्स क्या हो जाता है, अनस्टेबल हो जाता है. एंड दिस टाइप ऑफ पाई बॉन्डिंग इज कॉल्ड एज लिगैंड टू मेटल पाई बॉन्डिंग. This type of pi bonding is called as ligand to metal pi bonding. Please remember this. This type of pi bonding is called as a ligand to metal pi bonding. This is the first case. Understood? The first case. समझ में आई है सब लोगों को first case? Then we will see the case number 2. बोलो जल्दी से. Have you understood this or not? Case number 1. Have you understood this or not? कौन है आज के लेक्चर को, बोलो जल्दी से. Okay, Chetan, only Chetan is saying yes sir. What about others? दीपालीला पण समजले, चेतन आणि दीपाली दोघांना नाही समजले केस 1. ठीक आहे, चालेल. जरी काही अडचण असेल तर तुम्ही मला विचारू शकता. नाउ विल डिस्कस केस 2. क्या है केस 2? हियर case 2 is empty ligand orbital. Now here ligand orbitals are empty, they do not contain electrons, so they can act as an acceptor. So they accept the electrons from metal, and these empty ligand orbital they are high in energy. Now see here, you know that now you are very familiar with this T2G and Eg, and this gap between T2G and Eg star is called as a del 0, so it is a sigma complex. This is the situation in sigma complex. And in sigma complex formation, this T2G orbital they do not take part in the bonding, so they remains in anti-bonding, but this T2G orbital they can form a pi bond. So T2G orbital from metal and T2G orbital from ligands, they can form a pi bond, so they get combines and forms a T2G orbital which is lower in energy, so it is called as a bonding orbital indicated by pi, and again they gives forms another set of T2G orbital which is higher in energy, so it is indicated by star, so it is an anti-bonding orbital. So it is anti-bonding orbital. Now here in this case what happens, metal के जो T2G orbital है ना, they will go in lower in energy. So this T2G orbital they are bonding orbital, it is originally from metal T2G orbital. ये कौन से metal के T2G orbital, and those anti-bonding orbital T2G orbital they goes higher in energy, that is from ligand orbital. So this is a original ligand T2G orbital. And you know now the difference between T2G, you know now the difference between T2G from metal and Eg star orbital, it is called as a del O. See here, this is the T2G orbital, this is T2G orbital, and this is Eg star orbital, and difference between this T2G and Eg it is called as a del O, that is delta octahedral. And here in this case what happens, the magnitude of del O get increased. Here in this case what happens, the magnitude of del O get increased, and as you know that higher the magnitude of del O, higher will be the stability of the complex, higher will be the stability of the complex. Now when the metal donates electron to the ligand, in that case the magnitude of del O is get increased, and as the magnitude of del O get increased, it gets a higher stability, or it attains a greater stability. Okay, now what happens, we will see in this case. Now see, listen carefully. In this case T2G orbital goes to lower in energy, which was originally metal T2G orbital. Please remember this. Here in the second case, original T2G metal orbital they will go lower in energy, and due to this what happens, the magnitude of del O is get increased. Due to this the magnitude of del O is get increased, and as a result of this the complex becomes stable, and as a result of this the complex becomes stable, and this type of bonding is called as a metal to ligand pi bonding. And please remember this. This type of a bonding is called as a metal to ligand bonding. Please remember this. So these two cases are there in molecular orbital theory with pi bonding. Two cases are there. First case is ligand to metal pi bonding, and another case is metal to ligand pi bonding that we have seen. Okay, so we will see the next very important point. That point is called as a charge transfer spectra. This point is called as a charge transfer spectra. Now what happens due to this charge transfer spectra? Anybody know? Due to this charge transfer, the inorganic complexes, they becomes color. So inorganic chemistry is colorful chemistry, you know that very well. This inorganic chemistry is colorful chemistry. And why this inorganic chemistry is colorful chemistry? Because of this phenomena, and this phenomenon is called as a charge transfer spectrum. We have seen आप लोगों ने बहुत से सारे केमिकल्स देखे होंगे कि जो कि बहुत कलरफुल है देन द ऑर्गेनिक कंपाउंड्स. Inorganic compounds are always colorful compound because of the phenomena, and name of this phenomena is called as a charge transfer spectrum. The name of this phenomena is called as a charge transfer spectrum. One more phenomena is there, dd transition is there. Due to this dd transition also the complex get color, but this dd transition is Laporte forbidden transition. The Laporte is name of scientist who derived these rules, and according to these rules this dd transition is forbidden, which is not allowed, and this charge transfer transition is allowed transition. So this charge transfer transition is Laporte allowed, and dd transition is Laporte forbidden. So due to this what happens, due to this Laporte allowed transition, the color which is formed from charge transfer transition is more intense than dd transition. चार्ज ट्रान्सफर ट्रान्झिशनने जो काही कलर येतो ना तो dd ट्रान्झिशन पेक्षा कसा असतो, जास्त इंटेन्स असतो. ठीक आहे. सो विल फर्स्ट सी व्हाट इज एक्झॅक्टली दिस चार्ज ट्रान्सफर स्पेक्ट्रम. What is charge transfer transition, that we will see. So first of all, see the definition of charge transfer spectra or charge transfer transition. If you have pen notebook, you can write down this definition, which is very very important. So charge transfer transition is nothing but the displacement of charge density. Displacement of charge density, it is nothing but the displacement of electron. Okay, so displacement of charge density from one atom to another atom is called as a charge transfer transition. So displacement or transfer of charge density is nothing but the transfer of electron from one atom to the another atom. That is called as a charge transfer transition. And the graph of absorption, that is optical density OD, the graph of absorption or optical density OD versus wavelength of light is called as a charge transfer spectrum. And the graph of absorption versus wavelength, it is called as a charge transfer spectrum. And this charge transfer spectra is occurs due to what? Due to it occurs due to the transfer of electrons from one atom to another atom, one molecule to the another molecule, and depending upon the number of electrons or number of transition, you will get the number of spectra. For example, only one transition is there, you will get only one spectra, or only one peak you will observe. Sorry. If two transitions are there, then you will get two peaks in the spectra. If three transitions are there, you will get three peaks in the spectra. So this is a charge transfer spectra or charge transfer transition. This charge transfer transition is, I have told you, it is a Laporte allowed transition. This Laporte is the name of scientist. So this transfer transition or Laporte allowed transition, so it is more intense than dd transition. So it is more intense than dd transition. Again, here there are two types of charge transfer transition. Type 1 is ligand to metal charge transfer. It is called as LMCT. Two types of charge transfers are there. Type 1 ligand to metal charge transfer, and type 2 is metal to ligand charge transfer, which is called as a MLCT. Okay, so we will see or we will discuss this both the type, that is type 1 and type 2. Type 1 is ligand to metal, जो कि ligand electrons donate कर रहा है metal, and in second type metal donates electrons to the ligand. This second type na, it is called as a back bonding. This second type is called as a back bonding. Metal to ligand charge transfer. It is called as a back bonding that we have discussed while studying the chapter number 2, that is valence bond theory. Valence bond theory mein, it is one of the assumptions of valence bond theory, that is back bonding. Metal to ligand charge transfer of electron from metal to ligand. So what happened, initially sigma bond is formed, and due to the formation of sigma bond, metal gets the extra electrons. So metal ke paas electrons hai, so it acquires a partial negative charge, and to neutralize that partial negative charge, metal back donates electrons to the ligand, and that ligand takes it in from pi star orbital. That pi star is according to the molecular orbital theory. Please remember this. So the transfer of electrons from metal to pi orbital of ligand, it is called as a pi bonding. It is also called as a pi bonding, and it is also called as a back bonding. And this overall phenomenon, that phenomena is called as a synergism or synergic bonding. Okay, understood this? So we'll see the type 1 first. So type 1, that is ligand to metal charge transfer, it is called as a LMCT. Ligand to metal charge transfer, it is called as a LMCT. In this type of transition, electrons from ligand molecules to the metal atom takes place. As name indicate, the transfer of electrons takes from ligand to metal. Transfer of electron takes from ligand to metal, and this type of transition occurs, or it is generally shown by the ligands such as oxides, chlorides, bromides, iodides. When such ligands are there, then there is possibility of LMCT, that is ligand to metal charge transfer. Such transitions are favored when metal atom is in high oxidation state. Such transitions are favored when metal atom is in high oxidation state. जब metal atom more electropositive होता है, then such transitions are favored. So this is first type 1, ligand to metal charge transfer transition, and then type 2, which is metal to ligand charge transfer, which is called as a MLCT, metal to ligand charge transfer. So in this type, transfer of electrons from metal atom to ligand molecule takes place. So as name indicate, the electrons are transferred from metal to ligand, and this type of transition are shown by ligands such as carbonyl, cyanide, NO, etc. Such transition are favored when metal atom is in low oxidation state. First transition, that is LMCT, it is favored when metal atom is in high oxidation state, and second type, that is metal to ligand charge transfer transition, is favored when metal atom is in high oxidation state. Okay, so this is the end of this chapter. If you have any problem, any doubt, you can ask me. So I think we will stop here. अगर आपको कुछ डाउट्स है, प्रॉब्लम है, you can ask me. We will conduct one more test based on this chapter. In the maybe next week we will conduct the test. ठीक है? Okay. Now if you have any problem, any doubt, you can ask me. Yes, any problem, any doubt? Okay, sir. Everyone is saying okay, sir. No problem, no doubt. Now I have activated the link for your attendance. So you can give the attendance also. So finally we have completed the whole syllabus of your first term, that is inorganic chemistry. Inorganic chemistry का फर्स्ट सेमेस्टर का सिलेबस हमने ऑनलाइन फिनिश कर दिया है. जब हम लोगों का स्टार्ट हुआ था तो ऐसा लग रहा था कि ऑनलाइन कैसा होगा, ऑनलाइन समझ में आएगा नहीं आएगा, ऑनलाइन फिजिबल है नहीं है इंडिया में. सो वी डिड इट फाइनली, एंड वेरी वेल वी डिड इट. ठीक है. So how was your how was your experience of online teaching? You can share with me also. I will give you one form, that is feedback form. I will give you that feedback form. Maybe tomorrow or day after tomorrow I will give that feedback form. So in that feedback form you can share your experience with me. Okay. Now for today, if you have any problem, you can ask me. I will give 5 minutes for that. I will be happy to answer your questions. If no problem, then enjoy your day. We will stop here. And all the best for your university examination. चलो, है किसी को कुछ प्रॉब्लम? अरे यार, किसी को भी कुछ भी प्रॉब्लम हो? Rohan Sonone is saying thank you sir for what? Rohan. बोलो, if you have any problem, any doubt. अरे यार, किसी को भी कुछ भी प्रॉब्लम नहीं है? No problem. So, shall I stop here now? Shall I stop here? So, I think with this, now I will declare that the syllabus for your first term inorganic chemistry is over from my side. If you have any doubt, any problem, you can ask me. If you think we will again meet, sir, what will be the electronic configuration of CO, CN6? बहुत से सारे लोगों ने मुझे भेजा है. सोनल, I think तुमने भी मुझे भेजा है ना? So that we will discuss. So आप लोगों का यूनिवर्सिटी एग्जामिनेशन का टाइम टेबल आया है या नहीं आया? कब है आप लोगों की यूनिवर्सिटी एग्जामिनेशन फॉर दिस सेमेस्टर? आई एम नॉट टॉकिंग अबाउट बैकलॉग. दिस सेमेस्टर के यूनिवर्सिटी एग्जामिनेशन के टाइम टेबल आया है क्या आप लोगों का? अगर आया है तो प्लीज शेयर मी, प्लीज शेयर विद मी. एंड आफ्टर before your examination we will meet once again. आप लोगों के कुछ भी डाउट्स है आप मुझे शेयर करो and we will solve your doubts after 2 to 3 after before your examination. 2 to 3 days before your examination we will meet online. ठीक है? and in that lecture आप लोगों के जो कुछ भी सारे प्रॉब्लम्स है आप लोग मुझे अभी भेजोगे. जैसे अभी सोनल ने पूछा है कि व्हाट विल बी द इलेक्ट्रॉनिक कॉन्फ़िगरेशन ऑफ हेक्सासाइनाइड कोबाल्ट 3-. सो दैट विल सी इन दैट लेक्चर. ऐसे बहुत से सारे आप लोगों के प्रॉब्लम्स है बट फॉर दैट यू हैव टू स्टडी. अगर आप लोग पढ़ाई करोगे तभी आप लोगों को कुछ प्रॉब्लम आएंगे ना, तभी वो आप लोग मुझे पूछोगे जैसे कि अभी सोनल ने पूछा है. ठीक है? सो स्टडी हार्ड. If you get any difficulty, ask me. I will be available for you. 24 hours I will be available for you people. ठीक है? Not yet sir. पूजा is saying not yet sir. ठीक है? जेव्हा तू अभ्यास करशील पूजा तेव्हा तुला प्रॉब्लेम येतील. मी पहिल्यांदा सांगितलं. अभ्यास केला नाही तर प्रॉब्लेम येणार नाही. Very simple equation. ठीक है? Now shall I stop here? Shall I stop here? तो चलो ओके सोनल म्हणती ओके सर ओके चलो बाय बाय टेक केयर हैव अ गुड डे